So for the problem number 2, and just to recap, it's you guys have it in front of you, but we ended up at some point with 2x minus 4 equals 2x plus 1, right? How many solutions was that going to be? No solution, because it's parallel lines. Number 4 says, after simplifying the equation, Juana gets 6 equals 6. So that's true, but remember when we have an identity, and that's a fancy math word that I might slip and say. I try not to use too many fancy words. But an identity means that you have something equaling itself, right? And that's not actually the actual term. Well, it's part of the term, but an identity, and it's also the same root for identical. So if you could think about that. So what does that mean? It means there's infinitely many solutions, and then they want us to explain why. Infinitely many solutions. And basically, both expressions are equal. So you end up with something like 4x plus 2 equals 4x plus 2 at some point when you're solving it algebraically. When you get to something like this, you're going to have something like this. When you have an expression on the left-hand side that equals the expression on the right-hand side. And sometimes they might write it like this, like 2x plus 1, right? So you might, on one side, you might have something like this, but then when you distribute the 2 through, you're going to get the same equation, right? We've seen that before. So because they're the same, when you go to graph this, and we've seen this on our graphing calculators, the first expression, maybe it graphs in blue like this. Then what happens right after that? The next expression graphs in red, and I'm going to be on top of it, but not on top of it, so you can see them both. They're right on top of each other. They're the same line. So they intersect everywhere. And where they intersect when you graph the expression is where the solution is. If they intersect one time, it's one solution. If they're parallel lines, what's the noise for this? If they're parallel lines, they don't intersect at all. That means no solutions. But if they're the same line or identical lines, they're right on top of each other. They intersect everywhere. And so you have infinitely many solutions. Okay. Last one on the guided practice. How many, by the way, raise your hand if you got them right. Just one person did it? Okay, that's a little concerning. I'm going to slide this out a little bit so we could see the whole thing here. Maybe I could zoom in a little. Yeah, that's fine. All right, so let's do this next one. So we're going to solve, and then we're going to write down what we did to solve, okay? So they want us to write a linear equation with one variable that has infinitely many solutions. So that means you start off with 10 equals 10, right? So you start off with a true statement, right? Then you add the same variable to both sides. Remember, we did this already once. The same variable to both sides. I know that because they added 10. They added the x to 10 here. So on this side, I would say 10 plus x. Then they want you to add the same, what's the fancy word for just a number? Constant. Very good. Constant to both sides. Here they added 5. Over here you need to do the same. Whoops, that's not a very good 10. 10 plus x plus 5. And then you combine like terms. And you get 10x. Oh, I didn't combine like terms. What are the like terms? 15. Yeah, it's 15. So 10 plus 5 over here becomes 15. Well, I'm doing this backwards. This becomes a positive 15 here. Over here we do the same thing. 10 plus 5 becomes a positive 15 over here. And then you just carry down the 10x, or the x, because there's just an x by itself. So this would be x plus 15 and x plus 15. Now, if you look in the solution manual, they write it like this. X plus 15 and then is equal to 15 plus x. Technically, that's the same thing. That's probably how they'll do it in your homework. Okay, you might see it like that. You need to know those are the same thing. That's the commutative property of addition. And, 2 plus 3 is 5, but 3 plus 2 is also 5. So the order doesn't matter as long as you're just adding. Okay? Any questions on that one? No? That's it. Now, number 6, we're going to skip that one. Yes, question? Yeah, my ADHD is kicking in.